So hello students, today we will discuss the haloalkane and the haloarene units. So in this unit we have already discussed the preparations of the haloalkane. Now we are going to discuss the properties of the haloalkane. So haloalkane and the haloarene we will discuss separately haloalkane part and separately haloarene part. So in the haloalkane part, the preparation of the haloalkane you have already discussed the different method of the preparations of the haloalkane. Now we are left with the properties of the haloalkane. So today we are going to discuss the properties of the haloalkane. Now properties means there are physical properties and the chemical properties. So we will discuss separately the physical and chemical properties. The physical properties means what will be the boiling point, melting point, solubility. These are falls under the physical properties. And after physical properties, we will discuss the different chemical properties. So let's start the physical properties. The physical properties. Now in physical properties, we will discuss the boiling point. Now if we compare the boiling point of alkane, CC bond means it is alkane, and boiling point of alkyl halide, RX is alkyl halide. Now if we compare the boiling point of alkane and boiling point of alkyl halide of comparable mass, then which one will have higher boiling point? Now we know that boiling point depends upon the polarity. Polar molecule will have the higher boiling point than that of the non-polar molecule. Now out of the alkyl halide and alkane, which one is polar molecule? We know that polarity depends upon the electronegativity. If there is the difference in electronegativity, then the molecule is polar, and if there is no difference in electronegativity between the bonded atoms, the molecule is non-polar. Now RX halogen, R means carbon and X is halogen, so halogen has higher electronegativity as compared to the carbon. So halogen is del minus, R is del plus. So alkyl halide, there is difference in electronegativity between the halogen and the carbon. That is, the molecule is polar molecule. It is a polar molecule. Alkyl halides, it is polar molecule. Now alkane, the bond is between the carbon-carbon. That is, the bonded atom is similar. That is, there is no difference in electronegativity. So alkane, the bond is between the carbon atoms. So all atoms are carbon, all bonded atoms are similar. There is no difference in electronegativity. So the molecule is non-polar. Non-polar. So alkyl halide, polar molecule, alkane is non-polar molecule. We know that polar molecule has higher boiling point than non-polar molecule. So alkyl halide will have higher boiling point than that of the alkane of comparable mass. So number one, boiling point of alkyl halide and boiling point of alkane. So alkyl halide will have higher boiling point than that of the alkane of comparable mass, because alkyl halide is polar molecule, whereas alkane it is a non-polar molecule. So boiling point of alkyl halide is higher than that of the alkane. Next, number two. If we compare the boiling point of alkyl halide, RX. So X is halogen. This halogen may be chlorine, may be bromine, may be iodine. So RCl, RBr, Ri. So here alkyl group is similar. The dissimilarity is in the halogen part. So same alkyl group difference is in the halogen part. Now what will be the order of the boiling point? What will be the order of the boiling point? Now if the alkyl group is same, the difference is in the halogen parts, then boiling point increases with increase in the molecular mass. So chlorine, bromine, iodine, molecular mass. Iodine has higher molecular mass than that of the bromine. Bromine has higher molecular mass than that of the chlorine. So their boiling point will be in the order Ri, Rbr, Rcl. So if the alkyl part is same, difference is on the halogen part, then boiling point increases with increase in the molecular mass. So RCl, it is the lowest molecular mass, so boiling point is lowest. Ri, it will be the highest molecular mass, so their boiling point will be highest. So boiling point increases with increase in the molecular mass. If the alkyl group is same, difference is in the halogen parts. Now next number 3. Let's consider CH3, CH2, 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 Br. It is alkyl halide, molecular formula C4H9Br. There are 4 carbon, so C4H9, altogether there are 9 hydrogen, so H9Br. Again another CH3, CH2, CH, it is CH3Br. Here also molecular formula C4H9Br. Altogether there are 4 carbon, 1, 2, 3, 4. 4 carbon, 9 hydrogen and 1 Br. Next CH3, CH3Br. Here also molecular formula 1, total 4 carbon, 1, 2, 3, 4. So C4H9Br. So here molecular formula same. C4H9Br, C4H9Br, C4H9Br. Molecular formula same. Difference is in the structure. It is a linear structure. There is 1 methyl branching. There are 2 methyl branching. So molecular formula same. The structure is different. These are called isomer. So these are the isomeric alkyl halide. So for isomeric alkyl halide, what will be the order of the boiling point? So their molecular formula same, so their molecular mass will also the same. So all 3 isomers will have the same molecular mass. So in number 2 we have seen that the molecular mass increases, boiling point will also increase. Higher the molecular mass, higher will be the boiling point. Now here molecular mass is same. So what will be the order of the boiling point? So for isomeric alkyl halide, the boiling point decreases with increase in branching. If the branching is increases, the boiling point will decrease. There is no branching. There is 1 branching. This is 1 methyl branching. There is 2 methyl branching. So branching is increases. So if branching increases, the boiling point will decrease. So let it is A, it is B, it is C. So what will be the order of the boiling point? C, B, A. So these are the physical properties. Number 1 we have discussed boiling point of the alkane and alkyl halide. So alkane it is non-polar molecule, alkyl halide it is polar molecule. Polar molecule will have higher boiling point. So alkyl halide have higher boiling point than that of the hydrocarbon of comparable mass. Number 2, alkyl group is same, difference is in the halogen part. So for the same alkyl group, the boiling point increases with increase in the molecular mass. That is, alkyl chloride will have the lowest boiling point, and alkyl iodide will have the highest boiling point. Now, isomeric alkyl halide. For isomeric alkyl halide, their molecular formula same. That is, their molecular mass will also the same. So, what will be the boiling point? So, for isomeric alkyl halide, the boiling point increases with decrease in branching. If the branching is decreases, the boiling point will increases. So, in number A, it is a linear molecule, there is no branching. In number B, there is one methyl branching. In number C, there is two methyl branching. So, as the branching is increases, the boiling point will decrease. So, these are the physical properties of the alkyl halide. Now we are going to discuss the different chemical properties of the alkyl halide. The physical properties we will discuss in physical properties we have discussed the boiling point. Now we are going to discuss the different chemical properties of alkyl halide. So, chemical properties. Chemical properties means the different types of the reactions. Different types of the reaction. So, chemical properties. So, in chemical properties, we will first discuss the nucleophilic reaction. Nucleophilic reactions. Nucleophilic reaction means reactions with nucleophile. Nucleophilic reactions means reaction with nucleophile. Now, what do you mean by nucleophile? Nucleophile means any electron rich species is called nucleophile. Electron rich species are known as nucleophile, and electron deficient species are called electrophile. The nucleophiles are electron rich species. So, nucleophilic reactions suppose Rx plus nucleophile Nu. Nu means any nucleophile, then what will be the product? So, when alkyl halide react with nucleophile, what will be the product? So, these are called the nucleophilic reactions. So, now we are going to discuss the different nucleophilic reactions of alkyl halide. Clear? So, nucleophilic reactions means it is reaction with nucleophile. So, when alkyl halide reacts with different types of the nucleophile, then what will be the products? Now we are going to discuss this. So, reactions with nucleophile. Nucleophile means any electron rich species. So, first reaction with alkali. Reaction with alkali. So, here alkali is aqueous NaOH or aqueous KOH. Aqueous sodium hydroxide or aqueous potassium hydroxide. So, when alkyl halide RX, when it reacts with alkali NaOH, aqueous NaOH, the alkyl halide reacts with aqueous NaOH. What will be the product? So, here NaNX, sodium halide is eliminated. NaX, sodium halide is eliminated. So, here the residual part is R and OH. So, R and OH, we are getting the ROH plus NaS. So ROH, it is called alcohol. So alkyl halide when react with the aqueous alkali like aqueous NaOH, we are getting the alcohol. Here alcohol is the major product, here it is the side product. So in organic reactions, our target is only for the major product, not for the minor product. So alkyl halide when react with the aqueous alkali, it gives the alcohol. Now if it is aqueous sodium hydroxide, and what will be the product? So Rx plus suppose KOH aqueous. Now here KNX. KX is eliminated. So here residual part is R and OH. So here it is ROH plus KX. So alkyl halide on treatment with the alkali like aqueous NaOH or aqueous KOH, it gives the alcohol. ROH is called the alcohol. Now as for example CH3 CH2 Br plus KOH aqueous. What will be the product? So here KNX, KX is eliminated, CH3 CH2OH. So we are getting the CH3 CH2OH plus KBr CH3 CH2OH. What is the name of the product? CH3 CH2OH. Two carbon is called the eth. Then OH group, for the OH group, all the ethanol, CH3 CH2OH, it is called ethanol. So first reaction is the reaction with the aqueous alkali. So when alkyl halide react with aqueous alkali like aqueous NaOH or aqueous KOH, we get alcohol. So here what it gives? That it gives alcohol. Clear? Now this alkyl halide Rx on treatment with silver oxide moist, what will be the product? The alkyl halide on treatment with moist silver oxide. The silver oxide in presence of moisture. Moist silver oxide means silver oxide in presence of moisture. So silver oxide in presence of moisture. So when silver oxide Ag2O plus moisture means H2O. The silver oxide plus moisture. So 2 silver, 2 hydrogen and 2 oxygen. 2 silver, 2 hydrogen, 2 oxygen. So it is twice AgOH. Clear? 2 silver, 2 hydrogen. So 2 hydrogen, oxygen 2. So 2 oxygen. So twice AgOH. So moist silver oxide means silver oxide in presence of moisture. So silver oxide in presence of moisture, it gives the silver hydroxide AgOH. So moist silver oxide is nothing but the AgOH. Moist silver oxide is nothing but the AgOH. So here it is AgNX. AgX is eliminated. So here it is R and OH. ROH is called the ROH plus AgS. So it also gives the alcohol. Here also we are getting the alcohol. So alkyl halide on treatment with aqueous alkali like aqueous NaOH or aqueous KOH, it gives the alcohol. Alkyl halide on treatment with moist silver oxide, it also gives the alcohol. So this is the reaction, first reaction, that is reaction with the alkali and moist silver oxide. Next, number 2 reactions. Number 2 reaction is called the reaction with second reaction. Reaction with sodium alkoxide. This is called RONA. Reaction with sodium alkoxide. This reaction is also called Williamson's ether synthesis. This reaction is also called Williamson's ether synthesis. So alkyl halide, it is RX. When react with the sodium alkoxide is RONA. So NaOR, O minus Na plus, NaOR, it is called sodium alkoxide. So here it is NaNX, this sodium halide is again eliminated, so that is ROR. So product is ROR, it is called ether plus NaX. So alkyl halide on treatment with sodium alkoxide, RONA, it is called sodium alkoxide. So alkyl halide on treatment with sodium alkoxide, so NaX is eliminated, we are getting the ether. So this reaction is called the Williamson's ether synthesis. So ether is prepared, this ether is synthesized. So in this method ether is synthesized, and this method is called the Williamson's ether synthesis. So alkyl halide on treatment with the silver sodium salt of sodium alkoxide, it gives the ether. This reaction is called the Williamson's ether synthesis. So here it is R, that is alkyl group, and it is also R, it is also alkyl group. So these two alkyl group may be similar or it may also be dissimilar. Suppose here it is RX plus NaOR dash. So one is R, other is R dash. That is, it is also alkyl group, it is also alkyl group, but these two are not the same alkyl group. These are the two different alkyl group. Here it is R, here it is R. These two are the same alkyl group, but here it is the two alkyl group are not same. The two alkyl group are different. Product is same, NaX is eliminated. So here it is getting the ROR dash. NaX is eliminated, ROR dash plus NaX. It is also ether. So it is sodium alkoxide, it is also sodium alkoxide, product is ether. In the first ether, oxygen is bonded with the two same alkyl groups, so it is called symmetrical ether. And it is one is R, other is R dash, two sides are not similar, so it is called unsymmetrical ether. So in this method we can say symmetrical ether as well as unsymmetrical ether can be synthesized. Now in symmetrical ether two alkyl group is similar, in unsymmetrical ether two alkyl group is dissimilar. Dissimilar means the size of the two alkyl group is not same. One is smaller in size, other is bigger in size. Now which one is smaller in size, which one should be bigger in size? Two alkyl group is different, so one is smaller in size, others is bigger in size. So which alkyl group should be smaller in size and which alkyl group should be larger in size? Now if the two alkyl group is dissimilar, then alkyl group in the alkyl halide. Alkyl group in alkyl halide should be smaller in size than that of the alkyl group is sodium alkoxide. So alkyl group in alkyl halide should be smaller than that of the alkyl group in sodium alkoxide. That is, here R should be smaller in size than R dash. If R is larger in R dash, then the ether will not be formed. Instead, it is alkene will be prepared. So this is the Williamson ether synthesis. The alkyl halide on treatment with sodium alkoxide, it gives the ether. Ether may be symmetrical or it may also be unsymmetrical. For unsymmetrical ether, two alkyl part is different. It is their size will be different. One is smaller, other is larger. So alkyl group in alkyl halide should be smaller in size than that of the alkyl group in sodium alkoxide. Now, for example, CH3 CH2Cl plus CH3 CH2ONA. What will be the product? So here NaNX, NX is eliminated. So NaNCl, this NaCl is eliminated. So CH3 CH2, then it is O CH2 CH3, CH3 CH3 CH2, next oxygen, then CH2 CH3, CH3 CH2O CH2 CH3 plus NaNCl, it is NaCl, that is, it is symmetrical ether. So we are getting the symmetrical ether. Next reaction, suppose it is CH3 CH2Br plus CH3Ca CH3 CH2Br plus CH3C CH3ONA. So it is R, this part is R and this part is R dash. So here one is R dash, two group alkyl group are not similar. So one is larger in size, other is smaller in size. So here this one, that is, it is R, this is R and it is R dash, and we know that R should be smaller in size than that of the R dash. So here R is, there are 2 carbon atoms, and in R dash there are 4 carbon atoms. It is larger in size, it is smaller in size. So here R is smaller in size than R dash. So if the two alkyl groups are not similar, then this condition have to be satisfied. That is, R should be smaller in size than R dash. Now to be the product, the NaNCl, NaNBr, this NaBr is eliminated. So now the product is CH3CH2, CH3CH2. So this NaBr is eliminated. So CH3CH2. Next oxygen, that is O. Oxygen, after oxygen this is carbon. So after oxygen this is carbon. Oxygen, next carbon. Now this carbon is bonded with 3 methyl group. This carbon is bonded with 3 methyl group. So carbon is bonded with the 3 methyl group. CH3, CH3, CH3. This is the product. So here the two alkyl group is similar. So it is symmetrically the two alkyl group is dissimilar. So if the two alkyl group is dissimilar, then the R should be smaller in size than R dash. Then the Na and Br, NaBr is eliminated. This Na and this Br, NaBr is eliminated. CH3, CH2. After that, Na is removed. So we have to consider from this part, not from this carbon atom. Sodium is removed, so we have to bond will be from in that side where something is eliminated. Always bond is formed in that side where some group is eliminated. So sodium is eliminated, so bond will be formed with the oxygen, not with the carbon. So CH3, CH2, after CH2, this sodium is removed, so bond will be formed with the oxygen. So CH3, CH2, next oxygen. So CH3, CH2, oxygen. Now this oxygen is bonded with carbon, oxygen is bonded with carbon. This carbon have 3 methyl groups, so this carbon have 3 methyl groups. So this is about our Williamson's ether synthesis. Next reaction, number 3.